That's not by a little margin, but by a vast margin. Experts and competitors disagree. They say this assertion should be taken with a grain of salt, and that while Tesla's new hardware is amazing, it doesn't give the business an insurmountable advantage, nor does it eliminate the problems that self-driving cars face. Any firm with Elon Musk's name on it makes enormous claims, says Patrick Moorhead, a semiconductor analyst, and veteran of the sector. And sometimes things work out, and the rocket lands on a platform in the middle of the ocean, and sometimes it explodes in mid-flight. According to Moorhead, the promises made about Tesla's new self-driving processors fit this pattern. It could be a tremendous coup for the corporation, but it also has the potential to cause unneeded issues. I've been doing this for 30 years and I've never seen a perfect first chip, from anyone, says the narrator. It's a terrible waste of money and a huge distraction to me. Tesla, on the other hand, thinks its chips are worth bragging about, and its new hardware received a lot of attention on Monday. The event was kicked off by Pete Bannon, the company's project lead, who gave a full breakdown of the FSD's technical specifications. Musk sat next to him, ready to translate technical specifications into sound bites and boasts. Bannon is a well-known name in the sector, having worked as a semiconductor designer at Intel and Apple before joining Tesla in 2016. The FSD computer, he continued, will be Tesla's brain, processing data from 8 cameras, 12 ultrasonic sensors, a front-facing radar, and GPS and mapping data. This information will be utilized to guide the vehicle down the route. Tesla even boasts that the FSD computer, which it began installing in cars a month ago, can handle all of the computing hard work required to powerfully self-driving vehicles, if and when the software catches up. Each FSD computer is made up of a variety of parts, the most essential of which is Tesla's custom-designed chips, which are manufactured by Samsung. Each FSD has 2 chips, each with 2 accelerators dedicated to running neural networks, the AI components that Tesla's cars utilize to read the road. According to Tesla, each chip can conduct up to 72 trillion operations per second, and the entire system can analyze 2,100 frames of video per second, which is 21 times quicker than previous generation hardware. Although these are amazing figures, several experts disagree with how they were presented. According to Shapiro, Tesla compared the processing power of 2 of their chips to just one NVIDIA chip, and even then, they understated its power. They reported the performance as 21 tops, or trillion operations per second when it was 30, Shapiro adds. They deducted 30% from our actual performance. NVIDIA previously supplied Tesla's cars with semiconductors, and it continues to do so for many other firms in the field. Tesla's new chips, according to Shapiro, were also compared to NVIDIA's older technology, especially the company's Xavier computer, which was announced in 2016. According to Shapiro, a more accurate comparison would be with NVIDIA's new Pegasus computer, which has a processing speed of 320 TOPS. That's more than double the output of Tesla's new FSD gear, but at the cost of increased power consumption. According to Mike Demler, a microprocessor expert, and analyst with the Linley Group, this component of the presentation was deceptive. It wasn't even close to an apples-to-apples comparison. On a purely technological level, Tesla has created a major semiconductor. As Musk asserts, it's not the best thing since sliced bread. When asked if NVIDIA's technology could match the FSD computer's 2,100 frames per second processing speed, Shapiro said Tesla's presentation didn't provide enough information to address that question. I'm not sure what that standard is, he continued, so it's difficult for us to say what our performance would be. But, like NVIDIA, Shapiro applauded Tesla's efforts on the FSD, saying that the business knew that massive amounts of processing power were required to make self-driving cars a reality. The astute automakers understand it, Shapiro adds, but Tesla has a significant lead. Every day, I drive a Tesla, and it's incredible. Putting technical similarities aside, analysts believe the greater problem for the automaker will be the cost and inflexibility associated with developing its chip. The field of artificial intelligence is rapidly evolving, and as new methods to autonomous driving emerge, Tesla may discover it has backed the wrong horse in terms of chip selection. There's a risk in developing a semiconductor that's too precise, Demler warns. Did they make it flexible enough so that it can adapt as new algorithms are developed? While the field of self-driving cars is still evolving, Moorhead believes it would have been better to buy and customize chips from a different manufacturer. Tesla has a history of bringing production in-house to do things right, and it's a strategy that hasn't always worked out. For example, in 2017, the business purchased Perbix, an automated equipment manufacturer, only for Musk to concede the following year that it had depended too much on robots for car assembly, causing it to miss production targets. "I have the impression that the firm is painting itself into a corner," Moorhead says. However, all of this talk about chips and tops is, to some extent, a diversion. Without a question, processing power is vital for self-driving cars, but full autonomy poses fundamental obstacles that processors alone cannot address. Despite its claims of a self-driving future, Tesla still only offers Level 2 autonomy, which is a driver-assisted mode in which vehicles may accelerate, brake, and steer on their own but only in controlled environments with drivers ready to take control. Musk touted the integration of the company's new semiconductors as a key component in achieving full autonomy during the launch on Monday. "All cars being made have the components essential for complete self-driving, computer and otherwise," he stated. "All you have to do now is work on the program." Tesla will have over 1 million fully autonomous cars on the road by 2020, he added. These assertions, together with Bannon's extensive and impressive rundown of the FSD's technological specifications, may lead you to believe that self-driving automobiles are on the horizon. However, it's worth noting that Musk claimed the same thing about Tesla's vehicles in 2016. In the same year, he stated that by the end of 2017, a Tesla would be able to drive itself from Los Angeles to New York. It still hasn't happened 3 years later. So that's it for today. What do you think of our video? Let us know your thoughts in the comments below. If you enjoyed this video and would like to hear more from us, please subscribe to our channel and turn on notifications before you go. Thank you so much for watching us. Welcome to our channel. In this video, we are going to talk about financial crisis 2008. So before starting, please like this video, and subscribe to our channel for future updates. Tesla was formed in 2003 by a group of engineers who wanted to show that driving electric vehicles doesn't have to be a compromise, that they can be better, faster, and more fun to drive than gasoline cars. Tesla now manufactures not only all-electric automobiles but also renewable energy generation and infinitely scalable storage systems. The faster the world moves away from fossil fuels and toward a zero-emission future, Tesla believes, the better. The Roadster debuted Tesla's cutting-edge battery technology and the electric motor in 2008. From there, Tesla created the Model S, the world's first luxury all-electric sedan, which has become the greatest car in its class in every category. With the longest range of any electric vehicle, over-the-air software updates that improve it over time, and a record 0 to 60 miles per hour acceleration time of 2.28 seconds as tested by Motor Trend, the Model S has reset the world's expectations for the car of the 21st century. Tesla expanded its product line in 2015 with the Model X, the safest, fastest, and most capable sport utility vehicle in history, with 5-star safety ratings from the National Highway Traffic Safety Administration in every category. Tesla vehicles are produced at its factory in Fremont, California, and Gigafactory Shanghai. To achieve our goal of having the safest factories in the world, Tesla is taking a proactive approach to safety, requiring production employees to participate in a multi-day training program before ever setting foot on the factory floor. From there, Tesla continues to provide on-the-job training and track performance daily so that improvements can be made quickly. The result is that Tesla's safety rate continues to improve while production ramps. Tesla CEO Elon Musk made a big deal about the company's new microchips during the company's Autonomy Day event for investors on Monday. Musk said the new FSD computer, which stands for Full Self-Driving, that will power Tesla's vehicles had, objectively, the greatest microprocessor in the world, while describing it